Hey guys, welcome to this live session. Just give me a confirmation if you guys can hear me and if you guys can see my screen. I'll also wait for other folks to join in. And before we start off with today's session, I'd like to inform you guys that we have launched a free platform called as Great Learning Academy, where we have almost 100 courses with respect to domains such as data science, artificial intelligence, machine learning, digital marketing, and statistics. And the best part is once you complete these courses, you will have a course completion certificate. And you can use that certificate to either add it to your resume or you can also add it to your LinkedIn profile, which will be a huge value add to your profile. So the link for Great Learning Academy will be present in the chat. So you guys can go ahead and check out the description for that. And also, if you're interested in learning through an app, then we also have the Great Learning app. So you guys can check out the link for Great Learning app as well. And for all of the folks who are new to Great Learning, I'd request you guys to please subscribe to our channel, as that would encourage us to come up with more such live sessions and also upload more such high quality tutorials. And also you can go ahead and tell your peers, tell your friends or colleagues about Great Learning and how they can also skill up in this lockdown, so that they are ready and they can face new challenges once the lockdown is done. Great. So now that we're done with the introduction, so today's agenda is machine learning foundations. So what we're going to do is we'll understand what exactly is machine learning, and then we'll look at some basic subcategories of machine learning. Once we are done with that, we will go ahead and work with some libraries such as Numpy, Pandas, and Seaborn, which are very important when it comes to implementing any sort of ML algorithms. And then once we're done with that, we will go ahead and understand some ML algorithms, which would be linear regression, logistic regression, and decision tree. So if time permits, we'll be implementing a demo with respect to all of these three machine learning algorithms, or at least we'll try to cover one of these ML algorithms today. Right. So let's start off with a very simple question. What exactly is machine learning? To answer that, let's take this example over here. So what do you exactly see in this slide? What is this? It's a pen, isn't it? Now, what is this again? Well, this is a pen too. And what about this? Well, this again is a pen. And now, how do you know all of these are pen? When you immediately saw the picture of this, your brain immediately recognized that this is a pen. How is your brain able to do this? Well, this is how our brain functions. So when you're let's say very young, let's say when you're in kindergarten, then maybe you were told by your kindergarten teacher or maybe your parents that this is how a pen looks like, and your brain automatically registered the features of a pen. So your brain automatically understood how does a pen look like. So these are all the features. So basically, it understood the boundaries, the outer boundaries of how a pen needs to look like, and it immediately registered that. And whenever you would come across a picture of a pen or you would come across another pen, then you would immediately recognize that is a pen, and that is how our brain functions. Now that is all that is about how our human brain functions, and that is why we as humans are intelligent. But what if I actually use these images and I feed these images to a computer? So how will a computer be able to understand that these are actually pens? Because we have a brain, but does a computer have a brain? Well, it has a CPU, and that is what works as a brain for it. But the question is, how will this computer recognize these images as a pen? So what we'll do is we'll implement the same procedure as our brain works. So our brain, it was basically reinforced that when you looked at a pen, you were told that that is a pen, and that reinforcement of the picture of the pen is and that is how your brain learned that whenever you see a new picture of a pen, you will immediately recognize that as a pen. And that is what we'll be doing over here. So what we'll do is we'll take millions of pictures of pens. So you have pens of random shapes and sizes and or different colors, or you will take a ink pen, you will take a ball pen, you will take a gel pen, and all of them would have different colors. And what you'll do is you'll just have these millions of pictures of pens and you will keep on feeding them to this machine. Now, this machine learns all of the features from all of those million pictures of pens. And once that is done, this is known as the training. So what we're basically doing is we are training this machine over here. And once the training is done, we'll try to understand how much the machine has actually learned. So this is what is known as this computer. Now, if this machine is able to identify this pen or label this pen as this, then so instead of, let's say, pen, it could tag it as a pencil or it could tag it as an eraser. So that is totally upon the machine. And if it actually tags it as a pen, then that would mean that it has passed in the test. So its training was done successfully and it has passed in the test, and this machine has learned enough that whenever I give it a new picture of a pen, it will be able to tag it or classify it as a pen. And this, my friends, is what is known as machine learning, or this is the underlying concept of machine learning. So I hope everyone is clear with that. So if you have any doubts, you guys can post your doubts in the chat box. I'll take all of your questions parallelly. Amit Chaudhary is asking, identifying an object by a computer is ML or AI. So here you'd have to understand that AI is the superset. Inside AI, you will have something known as machine learning, and under machine learning, you will have something known as deep learning. So when you're training a machine to be intelligent, this is basically artificial intelligence. So you can't really separate ML from AI because ML itself is a subset of AI and deep learning is a subset of ML. So deep learning comes in where ML fails. So, and it's especially in domains such as computer vision and image recognition. Now what happens is when there are a lot of images or the resolution of the image is very high, then traditional ML techniques fail. And that is where you would have to use deep learning techniques. And in deep learning techniques, you would have to use something known as neural networks, and these are artificial neural networks. And to implement those artificial neural networks, you will be using deep learning frameworks such as TensorFlow, Keras, PyTorch, and so on. Isai is asking, how do we feed the data either through database? So data could be anything. So let's say if it's an image, then that image is actually represented as a matrix, right? Because if you just feed in an image to a computer, the machine will not be able to read that image. So you'd have to represent that image in the form of a Numpy array, which mostly comprise of zeros and ones. So this machine would be able to read this Numpy array which comprise of either zeros and ones. So if you talk about grayscale, then in grayscale you have numbers ranging from 0 to 256. So what you'll do is you will have a Numpy array or just an array which will have numbers ranging from 0 to 256, and then when you feed this to a computer, that computer will read this array and then it will understand the structure of the image. So that is how your machine works. Right, so if you have any questions, keep them posting. Great. So this was the underlying concept of machine learning. Now we'll go ahead and understand the different categories which are present in machine learning. So normally we have supervised learning, unsupervised learning, and there's also another category called as reinforcement learning. So reinforcement learning is mostly covered with respect to deep learning topics, so that will not touch upon today. And then today's class will mostly focus on supervised learning and unsupervised learning, which are the primary categories of machine learning, if I may say so. So first, let's start off by understanding what exactly is supervised learning. So in supervised learning, we obviously are dealing with data, but this data is divided into input variables and output variables. So the input variable is denoted with X and the output variable is denoted with Y. And what you're basically doing over here is you're trying to understand the relationship between X and Y. So here Y would be your dependent variable and X is your independent variable. Or in other words, you're trying to understand how does Y change with X. So that is why when you say how does Y change with X, Over here, y is basically dependent on x, and that is why y is known as the dependent variable and x is known as the independent variable. And in supervised learning, you basically have data which is labeled. So as in the previous example, we saw that we had image of a pen and we had a label with the tag pen. So over here, the image would be the independent variable and the tag would be the dependent variable. So let's say if I give you random images over here. So let's say if I have maybe an image of a car, an image of a pen, and an image of a laptop, and I have three different tags, and let's say I feed these three images randomly to the computer, and then randomly I'll also feed the tags car, laptop, and pen. Now, if the machine has learnt enough or it has been trained enough, then it should be able to correctly tag all of these images with the right labels. So this is how supervised learning works. You have independent variables and you have dependent variables, and you try to add the right label, or you try to find out the relationship between the dependent variable and the independent variable. So that was supervised learning. And then supervised learning, we have something known as regression and classification. Now again, in these two, let's start off with classification. So classification is basically the process of predicting the class of a new variable. It's very simple. So again, let's take this example over here. So as you see, we have an independent variable and a dependent variable over here. So here the problem statement is, if a person smokes, then what is the probability, or will the person have cancer? So this is the problem statement which you are trying to solve. So here our independent variable would become whether the person smokes or not. So this is our independent variable, and our dependent variable over here is whether the person has cancer or not. So on the basis of whether the person smokes or not, I am trying to provide a tag whether the person has cancer or not. And this is what is known as classification, or this is what happens under classification process. So as you see, we have labels and we also have input data. That was classification. And then we have something as regression. So also I'd like to point out that when it comes to classification, your dependent variable should be categorical in nature. So what do I mean when I say it has to be categorical in nature? So categorical is basically you have different levels, you have different categories. So this was a dependent variable, and as you see, this is a categorical variable. So over here the categories are yes or no. So yes, the patient has cancer, or no, the patient does not have cancer. So this is where we'll go ahead and use classification machine learning algorithms. Now on the other hand, if our dependent variable is actually a continuous numerical, so that is where we will use regression methods instead of classification methods. So here, let's say a perfect example could be if you're trying to understand if there's a relationship between the age of a person and the salary of a person. So here the salary of a person would be the dependent variable. So let's say over here y is the salary of the person and x over here is the age of the person, and we are trying to understand how does the salary of the person vary with respect to the age of the person. So here, let's say if this is the result over here, then this tells us that there is sort of a linear relationship between the age and the salary, or in other words, if the age of the person increases, the salary of the person would also increase. So here, since the dependent variable salary is numerical in nature, that is why we'll use regression methods. And for this particular problem statement, the regression method which we'll be using is linear regression. And as you see, we have a linear line over here which gives us the relationship or the linear relationship between salary and age. Right, so I hope you guys are clear again. Let me go ahead and see if there are any more questions. Sachin Yadav was asking how many libraries are used in ML. So that's a very vague question, I'd say. I mean, that totally depends on what you're trying to solve. Now, if you only want to implement ML algorithms, then for that purpose, you have a library called as sklearn or scikit-learn. And the scikit-learn library provides you different classes. So you have a class for linear regression, you have a class for logistic regression, you have classes for decision tree, random forest, SVM, Naive, and so on. So this library called as scikit-learn provides you different classes with respect to different ML algorithms. Similarly, let's say if you want to perform data manipulation, then you'll go ahead and use this library called as Pandas. If you want to do numerical computation, then you'll go ahead and use this library called as Numpy. And if you want to perform visualization, so let's say you've got a result, your ML model which you built has given you a result, but then again, you have to depict this result in the form of a beautiful graph. So that is where you go ahead and use libraries such as Seaborn and Matplotlib. So that totally depends on what problem you're trying to solve, and depending on that, you'll go ahead and use that particular library over there. Shweta is asking dependent variable, continuous or numeric in regression. So when you say continuous or numeric, it's basically the same thing. So when you say numeric, what is numeric? It's numbers. Numbers are continuous, aren't they? So over here, salary it's just numbers, isn't it? So salary can be maybe 10,000. It can be I don't know, 341. It can be 1,98,232. So you can have any value of a number, and this goes in a flow. So that is why it is either known as a numerical or a continuous numerical. But when you talk about categories, you only have a fixed number of categories. So let's say if you're trying to classify something into a color, and you only have 3 colors which you want to classify in. You either have blue, green or red. So here you only have 3 categories. So that is why you call it as a categorical variable. Similarly, in the earlier problem, we just had 2 categories, which was either the patient had cancer or the patient did not have cancer. So this is the difference between a categorical variable and a continuous numerical variable. Satyam Anand is asking what is the difference between classification and regression. So I've already explained that. So again, I'll do that if you have confusion. So what happens in classification is, so I'll go back this particular slide over here. Classification again is a supervised machine learning algorithm. So here what you're trying to achieve is you're trying to add a tag or a label to the input data over here, right? So your input data over here is basically what is telling you if the person is smoking or not. And if I know whether the person is smoking or not, on the basis of that, I would want to assign him the label of whether he has cancer or not. So here, this is our independent variable, this is our dependent variable. And this is a dependent variable because whatever is given to us with respect to this will be the result. And here, I call this as a categorical variable because you have only 2 categories. Either the person or the patient has cancer or the patient will not have cancer. Right? You're trying to classify over here. Either the classification is person does not have cancer or the next classification is person has cancer. I hope that answers your question. Amit Chaudhary is asking, so it means photo identification is classification? Yes, that definitely is classification. So over here again you have 2 different things. You have something known as image recognition and you have something known as image tagging. So image recognition, so what happens over there is, let's say if you just have a face or face recognition, what you call it. So in face recognition, it just identifies the outer boundary of your face. And let's say if you provide in a picture, your let's say a full body picture, and then this face identification, or what it does is it basically it surrounds your face with that square box. So this is how it happens over there. So let me see if there are any more questions. Madhukar is asking what is the difference between classification and clustering. Now clustering is an unsupervised learning algorithm. So we'll come to clustering as well. So right now just understand this. Classification is a supervised learning algorithm where you have data with labels. And since you have data with labels, you can categorize it into one of these labels. But when it comes to clustering, you have data with no labels. Right? You have no labels at all. But even though you have no labels, you try to cluster that data into some groups based on the similarity of the data points. So that is the basic difference between classification and clustering. So we'll just go ahead. So immediately after this slide, we'll go ahead to unsupervised learning and we'll understand the concept of clustering through that example. Rohan Kumar is saying justify the statement decision trees are used for both regression and classification problems. So it's very simple. So let's say if the question is whether if this is what we are doing over here, this is classification, and we can do this classification problem with a decision tree. Similarly, let's say if we want to find out the salary of a person over there, then to find out the salary of a person, there'll be different decision making metrics over there. So let's say first you will check the salary. That salary over there, let's say first you'll check the age. So age, let's say if you consider it to be a bracket of maybe less than 30 and greater than 30, right? So here age again is a numerical variable. So on the basis of that, you'll either go to left or right. Now let's say if age is greater than 30, then after that, let's say you would maybe want to check if the person is married or not, and again on the basis of that there'll be another question. So let's say what was his 12th class percentage, or what was his engineering marks. So on the basis of this you have different decisions, and finally you will come at the bottom, and at the bottom what you'll have is you'll have the average salary of the person. So this is how you'll be able to predict a numerical value as well. Right, so you're starting from the age, and from that you have different questions, and on the basis of those different questions you're making a decision, and then finally when you come to the leaf node you will have all of these average values of salaries, and that is how you can use a decision tree for both regression and classification. So now again, I believe most of you don't know what exactly is a decision tree, so we'll cover that if we have time in this session. Right, so that was classification and regression. So now that we are done with this, let's go ahead and understand what exactly is unsupervised learning. So till now, the base of supervised learning is we had labels associated with the data. Right, I hope everyone is clear with that. And now the base of unsupervised learning is you have data with no class labels. So let's say if I have all of this data over here, where I have images of different cars and images of different cycles. But if I feed this to a computer without labels, right, I'll not have any labels over there, and I'll just randomly feed in these images. So how can a computer understand which is actually what? So this is where a clustering algorithm comes in. So here what we're doing is we are applying a clustering algorithm on top of this unlabeled data, and this clustering algorithm gives us two groups. Now we have got these two groups, even though there are no labels, we've got these groups because this has been done on the basis of similarity of the properties. So here you'd have to keep in mind two things. So the first part is high intra-cluster similarity, and the second part is high inter-cluster dissimilarity. Now let's understand the first thing, where I'm talking about high intra-cluster similarity. So here when you look at the data points which are present in this group, right, so all of these data points are very similar, aren't they? Because all of them are cars. Now this is what is known as high intra-cluster similarity, because all of the data points are very same. Now similarly, if you look at this particular group over here, here again all of the data points are very similar to each other because all of them are bicycles. And that is why there is high intra-cluster similarity over here as well. But when we compare these two groups, so let's say when I compare group 1 with group 2, there is high inter-cluster dissimilarity, isn't it? Because you have cars over there and you have bicycles over there, and obviously both of them are very dissimilar when we compare them to each other. And this is the high inter-cluster dissimilarity which I'm talking about. So when you apply a clustering algorithm, which is basically an unsupervised algorithm on top of this unlabeled data, you are getting these two groups because this data in the first group is very similar to each other, and this data in the second group is very similar to each other. Right, I hope everyone is clear with this. So this is what is known as unsupervised learning. So we have covered the basics of supervised learning and unsupervised learning. So so seems like people haven't really understood what exactly is a categorical variable yet. Guys, do you want me to explain again what exactly is a categorical variable? or do you want me to go ahead with this? So just give me an answer. I'll just take up rest of the questions. Tushar is asking, is it possible to do forecast on ML model? Now, when you say forecast, I believe you're talking about time series forecasting. So time series forecasting is normally done with ML algorithms such as ARIMA. So there'll be a separate session on that as well. So over here, again, you can consider time series to be sort of a supervised learning algorithm where your X variable or independent variable is date, isn't it? Right? You have date which is fixed, and on the basis of date, you are trying to predict something. So let's say if I want to predict the number of coronavirus cases tomorrow. So let's say if I have the past data for the last month, then let's say if I have the number of coronavirus cases on the 1st of this month. Similarly, I have the number of coronavirus cases on the 2nd of this month. So here your independent variable or the X variable is the date, and Y variable becomes the it basically becomes the number of coronavirus cases. So you can call time series analysis to be a supervised learning algorithm where your independent variable is always date. So I hope that's clear. So I get a lot of guesses over here for categorical variables. So let's just go back to supervised learning. Actually, I believe you'll be able to understand this. Now, I hope at least everyone understands the concept of input variable, output variable, and independent variable and dependent variable, isn't it? So input variable is the data which we already have, and output variable or the dependent variable is something which we're trying to understand how will it change with respect to X. So give me a confirmation if you understand the difference between an independent variable and a dependent variable. So independent variable is something which goes onto your X axis, and dependent variable is something which goes onto your Y axis, and we're trying to understand how does Y vary with X. And you can understand it from the names itself, right? So I hope that's clear. So now that we know what is independent variable and dependent variable, in supervised learning we have regression and classification. And in classification, your dependent variable definitely has to be a categorical variable. Now, why is that? Because when you are doing any sort of classification, again, understand the nomenclature over here. Classify. When you hear the word classify, you only think of categories, isn't it? Or levels. You either classify this as A, B, C, or D. These are the levels which you have, isn't it? So let's say let me take another situation over here. So let's say if Virat Kohli is playing and your x-axis or your independent variable is the number of runs Virat Kohli has scored. And on the y-axis, you're trying to understand if India will win the match or not. So again, you only have two levels, yes or no. Will India win the match or will India lose the match? And on the x-axis, you have a continuous numeric variable, because it is independent. So independent, you can have the number of runs scored by Virat Kohli. And here, let's say if you somehow try to understand that, let's say if Virat Kohli scores more than 50 runs, then there is a greater probability for India to win the match. Similarly, if Virat Kohli scores less than 50 runs, then there is a greater probability for India to lose the match. Right, so I hope that's clear. So this is what I'm trying to explain over here. So in classification, your dependent variable has to be categorical. And when I say categorical, there are different levels in it. So one example is whether India will lose the match or win the match. Next example is whether the patient has cancer or not. Then let's say if you're trying to classify something. So let's say if you have to choose some colored dress for a party, and you only have maybe three colored dresses, three colored t-shirts maybe. So let's say you have red, blue and green, and you only have three choices. So this is something where you'll use a classification algorithm. Similarly, let's say if you're trying to predict, let's say, will it rain or not? So again, over here you only have two classes, yes or no. I hope that is clear. So now that we've covered a lot about this stuff, so we've understood the basics of supervised learning, unsupervised learning, and Again, we've understood what is classification, regression, and also about clustering. Now we'll go ahead and work with some of the main essential libraries which are required for machine learning. And one such library is Numpy. So Numpy is the core library for numeric computation. Now I say it is a core library because I've talked about arrays. As I've told you, if you want to do, let's say, image recognition, then that image is represented in the form of an array. And to create that array, you would need this Numpy library, because this Numpy library would help you to create single dimensional and multi-dimensional arrays. And it also provides you multiple functions or methods to implement on these arrays. Now that is out, let's see how can we create a single dimensional and a multi-dimensional array. To create a single dimensional array, first we'd have to import the Numpy array, and this is the command for that. So we'll just have to type in import Numpy as np. So over here, np, what you see is the alias for this library. Now once we have imported this, then we have this method called as array inside the Numpy library. So here we'll type in np.array, and inside this we are passing in a list of numbers which go from 10 to 40, and then we are storing this in n1, and when we print it out we get a Numpy array. So as you see, we have created a Numpy array by using this method np.array. So this was a single dimensional array. Now let's see how can we create a multi-dimensional array. So here we had passed a single list. Here the only difference is we'll pass in a list of lists. So inside np.array we'll have one list. So as you see, we have this outer boundary of square braces over here, and inside that outer boundary we'll have two more lists. So the first list, the numbers go from 10 to 40, and in the second list the numbers go from 40 to 10. And when we print out the result, in the first row we've got the first list where the numbers are from 10 to 40, and in the second row we've got the second list where the numbers are from 40 to 10. So this is how we have created this multi-dimensional array. So let's go to Jupyter Notebook. Now I'm not sure how many of you have actually worked with Jupyter Notebook over here. So Jupyter is basically a web-based interpreter for Python, and this would help you to code all of your Python stuff. Now our first task could be to import the library. So here I'll type in import numpy as np. Now that we've done this, I'd have to create an array. So here I'll type in np.array, and inside this let me just pass in some numbers. So I'll have 1, 2, 3, 4 and 5, and let me go ahead and store this in a variable called as n1, and let me print out n1 over here. So we have created a single dimensional array. Let me check the type of this. So inside type I will pass in n1, and as you guys see, this is a numpy nd array. So nd array is an n-dimensional array. Now after this we will go ahead and create a multi-dimensional array. So I'll store that in n2. Here I'll type in np.array, and inside this I'd have to pass in a list of lists. So this is the outer list, and inside this let me create an inner list over here. So I'll have 10, 20, 30 and 40. And let me go ahead and create the second list. Over here I'll have 40, 30, 20 and 10. I already have stored this in n2, and I just have to print this out. And as you see, I have created this two-dimensional array. So here the dimension size is 2 cross 4, which means that we have 2 rows and 4 columns. Again, let me check the type of it. So let me just write and type, and inside this I will pass in n2, and as you see, this again is a numpy n-dimensional array. Let me go ahead and check some more questions over here. So folks who have just joined, to inform them, today's live session is about ML foundations. So we understood the basics of ML, the different categories of ML, and now we are working with the Numpy library. And also, if you haven't yet subscribed to our channel, so please go ahead and subscribe to our channel, as we'll be coming up with a lot more live sessions, and we'll be uploading a lot more high quality tutorials. So please do that, as it will encourage us to keep you guys more productive in this lockdown. And if you haven't yet checked out Great Learning Academy, so Great Learning Academy is an initiative by Great Learning, which is a totally free learning platform, and over there you have almost 100 courses, and these 100 courses are with respect to domains such as artificial intelligence, cloud, digital marketing, statistics, and a lot more. And once you complete these courses, you will also get a certificate. So you'd have to either attempt a quiz or maybe some assignments or a project. So once you attempt these, you will get the certificate as well, and you can go ahead and add that certificate onto your resume or onto your LinkedIn profile, which would be a huge value add to you guys. And also, if you also, let's say if you're someone who's interested to learn through an app, so let's say if you don't have your laptop with you guys right now, so you can also go ahead and download the app. So the link for the Great Learning app would also be present in the chat. Right. So let me just go ahead and check some questions over here. So Amit Sharma is asking, how do we decide the array is suitable for a particular image? Now, when you load an image, so there are certain methods which would tell you the number of, let's say, what is the size of the image. Now, when you call an image to be, let's say, of the size 300 into 300, right? So obviously, when you look, let's say if you have an image, if you look, click on properties, then obviously you'll have something such as 256 into 256 or 300 into 300. What exactly is this? So when you say 256 into 256, that is basically the number of rows and number of columns present in it. Now, when you multiply 256 into 256, you will get those many cells. So you'd have to create an empty NumPy array which comprises of the same number of cells which are present in the image. And this is how you can go ahead and store that image in a NumPy array. Right, Amit Sharma is saying pixels. Yes, exactly. Right, so when you talk about 256 into 256, so you have those many pixels, and that is how many that is the NumPy array. That is the dimension of the NumPy array that you'd have to create over here. So, Graduate International is saying, can we enroll for only 2 courses? That is totally upon you. So on GLA, you can enroll for whatever courses you would want to. Jebin is saying your screen is blurred. So could others also tell me if it is blurred for everyone so that I can maybe adjust my settings over there, or if you guys can see my screen clearly? Mohammed Saddam is asking, if a list has both numerical and categorical data, how do we exploit the data? So you'd have to elaborate that. So are you asking how do we understand what is how do we identify what is the dependent variable or what is the independent variable over there? If you could elaborate more on the question, I'll be able to answer it. Randolph is asking, how is NumPy helpful with ML? So I've just given you an example over here. So let's say if you want to store an image, if the image size is maybe 10 cross 10, then you would have to create a NumPy array of dimensions 10 cross 10 and store the image in that NumPy array. And you can use that NumPy array, and let's say maybe if you want to do some sort of color manipulation. So let's say if it's a grayscale image, then maybe you would want to change the color of the image, or maybe you'd want to add some noise to it. So those are the different operations which you can go ahead and perform on that. Saurabh is asking, how many keywords in NumPy? I'm not able to understand your question, Saurabh. So what do you mean by keywords over there? Tushar Shinde is asking, he's basically suggesting to take one project from start to end. So we will do that. So if you want to go through one end-to-end project, then I had taken a session on the COVID-19 spread. So it was basically about predicting the COVID-19 cases with machine learning. So you guys can go ahead and check that video on the channel. We'll be uploading more such projects. So just register at Great Learning. You will know when more live sessions are scheduled. So for now, if you want to go through a project, you can check out the COVID-19 project over there. Satish is asking, can we have multiple x variables to forecast y in time series? If you talk about time series, then your entire x is basically date, isn't it? But when you talk about other stuff, so let's say if you want to predict salary, salary is your dependent variable. For this case, you can have multiple independent variables. So let's say for predicting salary, you can have one independent variable, which is age. Second independent variable, which tells us what was his 10th class percentage. Third independent variable, which would tell us what is his 12th class percentage. So here what we are doing is basically known as multiple linear regression. So when you have more than one independent variable over there, that is what is known as multiple linear regression. But when you talk about time series, your x is just date. Now when you talk about multiple independent variables over there, it doesn't make much sense, isn't it? Right? So let's say if you have date from this month or date from previous month or even date from 10 decades back, it's just date, and that is what you're dealing with over there. Right, so I'll take up the rest of the questions later. Now we've got only 15 minutes left, so we haven't covered much with respect to the practical stuff over there. Let's go ahead and quickly cover that up. So we have implemented a multi-dimensional array over here. Now let's see what else can we do. So now our task is to create a Numpy array which consists of only zeros. And again, first you'd have to start off by loading Numpy array. Then we have a method called as np.zeros, and inside that we will pass in the parameters which are basically 1, 2. So this is the dimension of the Numpy array. So when I pass in 1, 2, that will give me a Numpy array of size, or basically dimension of 1 row 2 columns, and it comprises of only zeros. Similarly, if I want a 5 x 5 Numpy array which comprises of only zeros, I will type in np.zeros over here, and inside that I will pass in 5, 5. And as you see in the result, we've got this Numpy array which comprises of only zeros. So let me just go ahead and type in np.zeros over here, and I would have to give in the dimension. So let's say I would want a 1 x 5 Numpy array, and as you see I have a Numpy array where I have 1 row and 5 columns and all of the numbers are zeros. Similarly, let's say if I want a 5 x 5 Numpy array with only zeros, so inside this method I just have to give in the dimension, and as you guys see over here, I've got 5 rows and 5 columns, and the only element which is there over here is 5. So that is how we could create a Numpy array consisting only of zeros. Now let's say instead of 0, I want to fill up the Numpy array with a particular number. So for that I have this full method. So here I'll be typing np.full, and this takes in 2 parameters. So the first parameter is the dimension, and I am setting the dimension to be equal to 2 x 2, and then I'll give in the value which will be the element inside this array. So in this 2 x 2 Numpy array, I am filling it up with only tens. Let's implement this. I'd have to use something called as the full method. So I'll type in np.full. Let me go ahead and give in the first parameter, which would be the dimension. I'll set the dimension to be equal to 3, 3. And let me give in the number. So I want to fill this Numpy array with the number 9. And as you see, we have created this Numpy array, a 3 x 3 Numpy array which only consists of 9s. So this was the full method. Now we also have the arange method. So if we want to create a Numpy array where we have numbers within a particular range, then we can use np.arange, and inside that we will pass in these numbers over here, and I just passed in 10 and 20. So here you'd have to keep in mind that 10 is the initial number and 20 is the final number. But 20 is exclusive. So when you're given 20, the numbers only go on till 19. So that is what is meant by exclusive over here. And we can go ahead and add another parameter, which is basically the skip value. So here the starting number is 10, the final number is 50, and we have a skip value of 5. So it starts like this: 10 plus 5 becomes 15, plus 5 becomes 20, plus 5 becomes 25, and it goes on and it stops at 45. Because when you add 5 more to 45, that becomes 50, and because 50 is exclusive, you can't go ahead more than that. But on the other hand, instead of 50, let's say if I had 51 over here, then I could have the next number, which is 50. So this is how you can work with np.arange. So let me also go ahead and write it out over here. So np.arange, and inside this, let me just go ahead and what I'll do is I'll give in the range over here. So if I want numbers from 1 to 10, I'd have to give in 11 over there because 11 is exclusive. And as you see, I have all of the numbers starting from 1 and going on till 10. And now I will have a skip value. So this time I want the numbers starting from 100 going on till 500. I'll actually change it to 501, and the skip value needs to be 10. So this time I have numbers starting from 100 going on till 500, and I have a skip value of 10. So 100 plus 10 becomes 110, plus 10 becomes 120, plus 10 becomes 130, and it goes on and stops at 500. And since 501 is the last number which you gave, so it stops at 500 over here. So this is np.arange for you. So let me just take up some questions now. Priyanshu Kumar is asking, can you provide the list of courses to go through for understanding ML? So for any data science purpose, I always state this, that if you are, let's say, new to data science, and if you want to start your journey as a data scientist or a machine learning engineer, then there are 3 basic pillars which you would have to master. So the first pillar is statistics. So you would have to be really good with statistics because it forms the base for machine learning and artificial intelligence. So if you're not good with statistics, then you cannot be good with data science or machine learning. So we have a full course on statistics. So that is by Dr. Abhinanda Sarkar, who's got his PhD from Stanford. So you guys can go ahead and check out the statistics for data science course on our channel. Now in statistics, I'll just list out some of the topics which you'd have to learn. So you'd have to understand about measures of central tendency, measures of deviation. Then you have something known as central limit theorem. Then you'd have to understand about hypothesis testing. Then you'll go ahead and understand some probability concepts. So there you'll understand about let's say Poisson distribution, binomial distribution, and so on. And if you're done engineering, I believe you would be learning about probability, conditional probability, probability distribution, and so on, because these were some of the topics which were taught to me during my engineering days. And once you're good with stats, you can go ahead and learn either R or Python, because right now in the industry, these two are the most popular and most widely used languages to implement machine learning. So both of them go neck to neck. So R is used mostly for statistical purpose, and Python is used mostly for machine learning and deep learning. So I'd actually say to learn both R and Python, because it shouldn't take much time to have expertise in either of these languages, because both of them are very simple. And once you're good with these two languages, then you can go ahead to the ML algorithms. So in ML algorithms, you can learn about linear regression, logistic regression, decision tree, random forest, SVM, Naive. So just cover up all of the basic algorithms, understand what is the mathematical concept behind these algorithms, and try to implement these algorithms from scratch by yourself. Right, so you can check out, so we have courses with respect to stats, Python, R, and also the ML algorithms. You can find all of them on a YouTube channel. So if you follow this, I'm pretty sure you will, you will learn all of the basic stuff required for, required to get on with the data scientist job profile. Graduate International is saying I had a session on OOPS because I had missed hybrid inheritance. Sure, we'll definitely have a live session on object-oriented programming. So again, the list of live sessions, you can just check them out in Great Learning Academy. So we'll note this out, and we'll have a live session on OOPS either next week. So we'll try and arrange that. Right. So rest of the questions again, I'll read up later because I've just covered up Numpy till now, and let's go ahead to the other stuff. And now, once we're done with numerical computing, let's see how can we do data manipulation. So to do data manipulation, we have this library called as Pandas, and it is the core library for data manipulation. So just as NumPy gave us arrays, Pandas would give us certain data structures called as series and data frame. And series is the single dimensional object, and the data frame is the multi-dimensional object. So first we'll go ahead and work with the series object. So first, to work with the series object, we'd have to import the data frame. So here we'll type in import pandas as pd, and once we import it, we'll have to create the series. So here we'll type in pd.series with a capital S over here. So if you don't use capital S, then you'll get an error. And inside this, again, we are passing in a list of numbers. So as you see, we are passing in these list of numbers over here, and we are storing that in S1. And this is the series object which we have, and then we're just checking the type of this. So this is how we can create a series object. So let me go ahead and import pandas. So here I'll type in import pandas as pd. We are done with this, and I'll have to create a series object. So here I'll type in pd.series, and inside this, let me just pass in some numbers. So I'll have 1, 2, 3, 4, and 5, and I will store this in an object called as S1, and I will print it out over here. And this is the series object which we have over here. And here you'd have to understand that these labels, the indexing starts from 0. So the element 1, index of element 1 is 0, index of element 2 is 1, index of element 3 is 2, and that is how it goes on. So indexing of a series object, or in general anything in Python, it starts from 0. So we have created the series object. Now let's say if we want to change the index over here, we can also do that. For that purpose, we have this attribute called as index, and inside this we will just assign the index values which you'd want to give to this. So let's say instead of 0, 1, 2, 3, 4, if I want alphabets over here, so I'm just giving in alphabets which go from A to E. So I have A, B, C, D, and E. And as you see, 0 is replaced with A, 1 is replaced with P, and that is how it goes on. So let's make these changes. So this is the same command over here, and here I just have to add a new attribute called as index, and I'd have to pass in a list of values. Inside this, I'll have A, B, C, D, and I'll just have E over here. And let me run this. So initially, as you had seen, we had numbers 0 to 4. Now we have changed them to alphabets which start at A and go on till E. So this was a series object. Now let's see how can we extract individual elements from a series object. So to extract the individual elements, all you have to do is use the parenthesis. So again, as I said, index starts from 0. So let's say if you want to extract this element, which is actually at 4th place. So if it's at 4th place, the index would become 3 because 0, 1, 2, and 3. So here we just have to type in S1, 3, and we'll be able to extract this element, which is at index number 3 or position 4. Similarly, if I want to extract a sequence of elements, so if I want the first 4 elements, so I'll type in S1, and inside parenthesis, first I'll give in colon, and then I'll pass in 4. And as you see, I have extracted the first 4 elements over here. And if I want to extract the last 4 elements, so here first I'll give in the number, and I'll have a prefix minus. So I'll type in -3, and then I'll put in a colon. And as you guys see over here, I have extracted the last 3 elements. So this is how we can extract a single element, a sequence of elements, and a sequence of elements from the back. So let me just create another NumPy array over here, s2 pd dot series, and let's say I have 10, 20, 30, 40, 50, 60, 70, 80, and 90. And let me just print out S2 over here. Now out of this entire series object, I just want to extract, let's say, this element 50. So let's see the index. So this will be 0, 1, 2, 3, and 4. So I'd have to type in S2 inside parentheses. I'd have to give in 4. And with the help of this, as you guys see, I have extracted this particular number over here. And similarly, let's say if I want to extract a sequence of elements, let's say if I want the first 4 elements, which are from 10 to 40, I'll just give in S2 over here, then I'll give in a colon. And since I want the first 4 elements, I'll type in 4 over here. So I have extracted the first 4 elements. And if I want to extract the last 3 elements, I'll have S2 parenthesis, and I'll have minus 3 over here because I want 3 elements from the last. Then I'll give in a colon. And as you guys see, I have extracted the last 3 elements, which are 70, 80, and 90. So these are some basics of the series object as well. Right, so we are left with a lot of stuff. So we are left with data frame over here, and we also had to cover the visualization stuff, and we had to implement linear regression, logistic regression, and decision tree. So all of that, what we'll do is we'll have a consecutive session, and in the next session we'll be covering about linear regression, logistic regression, and decision tree. We'll understand the concepts of it, and then we'll also go ahead and see how to implement them with the scikit-learn library. So for now, I'll sign off. Thank you very much for attending the session. And again, just to inform you guys, if you haven't yet subscribed to our channel, please go ahead and do that. And if you guys haven't yet registered at GLA, please go ahead, as you'll have a lot of free courses over there, and you'll have a course completion certificate, which you can add to your LinkedIn profile or to your resume. And if you want to learn through an app, we also have the Great Learning app over here. So thank you very much, guys. I'll sign off for the day.